Good morning and afternoon, everyone. Welcome to today's live stream. This is Wayne Griffenberg. I'm a technical specialist on the Fusion team at Autodesk. Today we're going to do our deep dive into joints and basically into assemblies. And we're going to do our deep dive going through bodies versus components, some joints, joint origins, rigid groups. We'll talk about motion links, contact sets, and motion studies. So today we have Tyler Kakara on the keyboard to answer some questions as we go through. We have a lot to cover today, so I'm going to just jump right in. So please feel free to ask questions. We're here to help you with answers, and as we go through deeper towards the end, we can get some answers for you. So I'd like to just jump right in and talk about a story. My son and I have been making guitars in our garage. We got an X-Carve, and this is actually one of the whole guitars that we're working on and building is a whole Stratocaster there, style body. And just to get some practice on this X-Carve, we set up our stock with our clamps. And the coolest thing is being able to have the actual machine that you can move around and see if we're going to hit any clamps. You can see it from different directions. And as we go in, I can know areas to avoid where I can see it's really close to those clamps to be able to hold down our part. So a neat thing about assemblies is being able to set up the machine that matches what you're running and be able to have some joints that can move on the X, Y, and Z axis that are set up for slider joints and such, right? So I'm going to walk through some of that process. By the way, the models for this assembly you can find online. These were downloaded. I went right to the Xcarve website, which brought me through to GrabCAD, and you can find all the models for this particular CNC machine to download them here to be able to work on them. So I'm going to come back to this assembly in a little bit because I'm going to show you how to do a motion study in here. But I really want to focus in on describing the difference between what's bodies and what is components, right? So, and we also talk about a concept of top-down versus bottom-up design in assemblies. And we're going to dive into those concepts. I'm going to give you a precursor. We're going to work with a vise similar to this one. And in this one, I applied a motion link. Well, I will apply a motion link in here to be able to move and move this vise back and forth according to the actual threads in there, right? So we're going to do that, but I'd like to jump into a very basic design really quickly. We're going to start from scratch. Um, let's say we want to design and make something like a very simple jewelry box, right? So I want to jump into have a very um, quick overview of bodies versus components. So initially, when you start a design, think about what your design intent is. So if your intent is just to make a single model, that's what we're set up here for. And if my intent is to make an assembly, there's a different workflow that you would go through to turn this into an assembly, right? So I can start to design from the top down versus bottom up, which means top down means I'm going to start to design in place all the components that make up the overall top assembly. Bottom up means that I'm going to go and import different components and bodies and bring them into our environment as single components that we put together and add joints and so forth. So a quick instance of working with a top-down design. So the first thing I'm going to do is show you we can design a body, of course. So as I go into a plane and I start to create a sketch, and the sketch is applied directly to our top level body or whatever this is going to be. So in that sketch, I can start to create something like a rectangle. We'll do this really quick. And we're going to make a center point rectangle, and we're going to add some dimensions. We'll make it 6 inches by 10 inches rectangle. And I can give this some 3D shapes. So now we have this sketch. I'm going to jump into a solid workspace and extrude this up into some height, let's say 5 inches. So now we just made a block, a simple block. And that block now has its body, right? So now we have a single body and we have a single sketch. And in our timeline, we have the sketch we use to create the body, and we have our extrude, that makes our solid model or solid body in the end. So what we basically have is just simply a body. Now, if your intention is to make an assembly, and I'm going to show you a neat way to control your design through parametrics and also use a top-down method to make a box, right? So let's say we're going to make a jewelry box. It'll have a base to it and it'll have a lid to it. Now, what I did is I designed this cubic space. I basically drew a cube in here that takes up some volume. And we can make this parametrically driven. So let's say we go into our modify. I'm going to create some parameters in here, right? So we're going to add a parameter for width, and we're going to make that, let's say, our 10 inches. And we're going to add a parameter for our length, and we're going to make that like 8 inches. So we're going to make a little bit of a change there. And we're going to add another parameter for our height. And our height would be something like 5 inches. And then so you kind of determine what what has that overall view of the part. So hopefully you guys can hear me okay. I'm just trying to check in and make sure that you guys are okay with hear me. And so what makes that box, right? What is this box going to be? It's going to be the space that I want to take up by my assembly. So now we don't have any components yet. So in here, we're going to create a thickness for our assembly components, right? So I'm going to call this one thickness. And in here, we're going to give it some value, let's say a 1/4 inch. And we're going to use these values directly in our design. So in our sketch, let's show our dimensions really quick. And I want to apply the width. So I'm just going to type in width, and I apply the width to this dimension, and now it takes on our width. Same thing for our length. I'm going to apply the length dimension, and it takes on the length. And for our height, we can just simply go to edit our feature. And there's going to be our height. I'm going to start typing in our height. And now we have our height parameter in there. So this basically is cubic space. So now let's turn it into an air body, if you will. So I'm going to apply some physical properties to it, right? So let's go down and apply physical material, and I don't want it to take up any volume of our design, so we're going to turn it into air. So if we do some analysis later on, it doesn't have any effect on our design of the assembly. So now I'd like to also change this opacity, and we're going to make it, let's say 40%, so we can at least see our boundary. Now let's start to design our components. And this is when you work with your top-down design. We have a body in here and a sketch as we had established, and this is basically a body part. Now I'm going to create an assembly simply by adding a new component. This component, we're going to call this one our base for our box that we're making. And now you'll see we now have a base component inside of an assembly. You see the icon changed to become an assembly now. So now we have our original body, that's basically our cube, and now we have a base component which has its own origin. It'll have its own sketches in its own body. So I'm designing this directly in place, right? So now we have this base, and what I'd like to do is now we're going to make a lid component, right? So we're going to add a new component. I'm going to take a shortcut, right click, add a new component, and now we're going to add this and call it lid. So now we have two components inside of this assembly with the original body that we're going to use to drive it, right? So let's go into our base. I'm going to activate our base component. I'm going to start to design in the base the block body, right? So let's say I'm going to take this bottom face. I'm just going to start to do a direct extrude right from that bottom face, and we're going to start to build up the body, right? So let's say we're going to have this height minus the thickness, right? So we're going to make whatever that is. I'm going to type in here our distance. We're going to make this our negative height. And I'm going to make this minus thickness so we have room for the lid. So our height, actually I'm going to make it plus since we're going negative height. We're going to make it a plus thickness so we have room there. So now I was able to drive that with parametric design. We now have a body inside of our component. And we also have our body that's helping us drive it, which is our cubic space. So what I'd like to do is now for this base, I'd like to shell this out really quick. So we're going to do a quick shell. And of course, we probably won't make it this way if we're like, going to route it out and so forth. But maybe we'll 3D print this jewelry box, right? So we're going to give it a shell and we're going to call this our thickness of the shell. So now we shelled out our box, right? So we have the box component, right? And this is our base. So let's call it the base component inside of our assembly, right? So we have the original body we created. We have the base component, which is inside of that top-down assembly, right? So now let's make our lid. So I'm going to turn on at visibility of our body, our initial body that we had. So let's go down here and we're going to show it again. So now I started off, if I hide our base component, I started off now with this base component being our body of air, and we added the base component to it, and we extruded up and created that base component from our initial body. Now I'm going to switch over to the lid component, and on the top of the lid component, we're going to extrude this now and make it become a lid of our box. All right, so I'm just going to grab that top of the body. Okay, so let's extrude this down. Right, we're going to do a quick, instead of press pull, we're going to do an extrude. We're going to grab that top face and we're going to start to pull it down and make it the thickness. Right, so we're going to go negative thickness. And now we have our basic lid there. Oh, did it take it? Oh, there we go. So we're going to go this distance, negative thick. There we go. And now we have our lid component, right? So it's very basic, very simple. I just want to show you that you can create components inside of a design. Now these are individual components. So if we go back to our and activate our top level design, now we see we have the individual components based upon that initial cube. So if you actually go in and change your parameters, and we make this instead of 8 inches in length, we're going to make it 12 inches, you'll see all the components grow with that initial boss size or base size. Right, so now we can assemble this. I'm just going to undo a couple times and bring us right back where we were. Now, for our body, we can leave our body where it's at. It's not going to move around, but our components, we can now say our base, we're going to ground it where it's at. And now we have our lid, if you will, right? So I could take our lid and we can move it around and work with the lid directly. And I'm going to hide our body, which was our initial cubic space. So this is a smart way to design. So all of your components are based off that cubic space of the body, but each of these components are now individual components that you can make or and work with. So now I'd like to just jump right in and talk about some basic joint um, capability. Right, so you can use joints to align and create assemblies to assemble the components together. Right, so in assemble, where we have our joint, we're trying to mimic the way the part's going to work in the real world, right? So if you have, in this case, like if you look at the clamp, you're actually going to have a slider joint and rotary joints and so forth. Instead of using that method of trying to lock down the 6 degrees of freedom, where you select different faces, different planes, and different edges to try to lock down their 6 degrees of freedom, we're going to apply a joint to do the same, right? So I'm going to assemble this via joint. And right now what's popping up is capture position. So Fusion 360 keeps track of where the components are, the origins of the components in space. So as I move the lid out of place, Fusion's keeping track of where that origin is, so when we make changes, it knows exactly where to apply them. You can continue, which will snap it right back to the original position, or you can capture the position. That's this position marker up here. So if you capture the position, means it's now going to lock in on our timeline a position marker, and this is keeping that marker from where I move the lid into space, and it's recognizing that distance. So we went into our joint. So the first component is always your moving component. That's the one, let's say if you're making a housing or you're putting a cylinder head or you're putting a valve cover onto an engine, the valve cover and engine are your fixed components. The bolt that you're going to screw down into it is the first moving component. So the first moving component in this case is the lid. So I'm going to select the lid. Now, when I hover over, notice we get this happy face, if you will. This is a coin, right? This represents a coordinate system. So as I move it around, you can see it's going to change direction, right? I can choose this side of the face, and you can see it'll even choose an edge and become normal to that edge. So what we're doing is we're applying a coordinate system to a specific place and a specific origin on our moving component. Now, we use the coin um, as a coordinate system. It's the if you picture the upper lip of the happy face is the x-axis, perpendicular to that is the y-axis, and the z-axis is always normal to the face that you're selecting. Right, so we use this coin opposed to an x, y, and z axis because we don't want to have any confusion with this origin up here. Right, this x, y, and z has nothing to do with what we're using to make this coordinate system here. So I'm going to select that center point. It now establishes that as a coordinate system. The next component is our component 2 that we want to select. Now, right now, because I designed this with that little body in mind, I do have that body we can apply this coordinate system to. But notice that I can hover over each of these different edges and these different arcs, right? So let's say we want to be able to apply that. I'm going to turn our body on, and now I can actually align it with the center of our 3D body, right? The cube that we created of air. It's floating on top. I can always move and offset that down a 1/4 inch or by the thickness, right? So we could say we'll move that down a 1/4 inch, and now we can apply that lid right on top of our box, and our coordinate systems are lined up. But did you notice when I put it there, it started sliding back and forth? We can apply motion directly to the joint to mimic the way it's going to work in the real world. Right? So right now we have a y-axis, so it's going to slide back and forth on the y-axis according to the way we set up our coordinate system. If I change this to x-axis, you'll see it'll slide along the x-axis. And of course, the z-axis will move up and down normal to the faces we selected. So you can apply different types of joints, cylindrical joints, pin slot, planar, and ball joints you can apply to your design. So I'm going to leave this as a slider joint. We're going to say OK. And now we have this slider joint that mimics the way, let me turn off our body. This is going to mimic the way it's going to work in the real world. Now, of course, it's going to go right through the body. Now, we can set joint limits so that we have it sitting at our 0, and we can have it go up to a certain height we'd like it to. If you notice, we now have a joints folder in this design. And in our slider joint, we can always edit that joint. Right? We can also change our joint limits. So and this is our range of motion. So at our minimum, we could set it at 0 when it was sitting on top of the box. At maximum, we could say whatever height is required. So if I put in 8 inches, it's going to move up 8 inches. So now we limit that joint from 0 to 8 inches. Now it's similar. This is actually applying a joint limit directly to our component. Now, somebody had asked, what is the difference between that and a drive joint? So drive joints are really trying to help you mimic the way it's going to work at a one-time movement, right? So I could say drive joint, I could select our joint. I'm going to say, I want to see what that's going to look like when my distance is, let's say, 1 inch. So now I can apply a drive joint, and this would actually apply a lot more when you're trying to do more motion study type operations. But a drive joint is basically, it lets you kind of drive it. It lets you put in, let's say, 2 inches, what's going to happen. And if I make this at, let's say, 8 inches or 9 inches, it doesn't do anything because that's outside of our limits, right? So let's say I'm going to make this go to 5 inches, and you can see now I can actually drive it to 5 inches and say, okay, now we're locked at 5 inches. So I'm going to show you, and I started to go into one of the vise examples where you can actually set a drive between these vise jaws. So if you have a limit where it's set, you can also add a drive joint or a drive link between them that you can keep that at, say, 5 inches, so you're going to drop some stock in there at 5 inches. So I just want to give you an example of how that would work. Right? So that's an example of top-down design. We were able to create our body that represents, it represented our air right? So if I look at this body alone, so we have this body that I created, and it's simply a body, it has its own sketch and reports to the top level of the assembly before we even had an assembly. And we turn this into air. We have this basic space that we're using, the cubic space, and around it we applied some components that we designed directly from that body, right? So it's work smarter, not harder, right? So now we have this lid component, again, very simplistic, but we have this lid component that we added a joint. Now, let's say we wanted to have this be a hinge joint, right? We can always insert a hinge, download from McMaster Car or make your own hinge and design it. So let's say we didn't want, in this case, the slider joints. I'm just going to right click and we're going to delete that out for now. I'm going to add a hinge type joint, right? We do exactly the same thing. I'm going to go into here and add a joint, capture the position where it's at in space. We're going to choose our first component, and in here I'm going to select this edge. And notice now the coin, if you will, our origin is now going normal to that edge, and I can even snap it to the center line of that edge. Now I have this x-axis in this direction, the y is perpendicular, and the z is going to go along this edge. Now I'm going to select the second component, perhaps this edge, and we're going to apply just the opposite joint. So now we have a slider joint, so I can just simply switch over. I'm going to call this a revolute joint, and now we actually have a hinge condition, right? So now we can take this and lift it up as if we have a hinge on the box, and we can, of course, do this with a hinge component. And now I can move that box up and down. Of course, you see it goes into our model, and you could set up, again, we could do a drive, but first we want to set up our limits. We can right click, edit joint limits, and now we can say our minimum will be our 0 condition, and our maximum could be something like 90 degrees, so it lifts up at 90 degrees. So now we can limit it so it doesn't go into our box and it only goes 90 degrees. So the same exact workflow we did to make the slider joint, we just made a hinge type joint, a rotation joint, directly on the body itself. So hopefully that helps to kind of give a little bit more clarity on working with top down versus bottom up. And we're going to show you a little bit more in bottom up in just a minute or so. But that's applying some joins, applying it to a top down design in an assembly. All right, so what I'd like to do is I want to switch a little bit of gears here. So in our assembly, we talk about joints, and right underneath of it is an as-built joint. And there's a nice utility blade there. And we happen to have one, so let's open that up. If you go into your main documents, go all the way back to your root documents back here, you'll find that in a section down here where you have basic training, and in assemblies, you'll find a lot of these examples that I'm going to show you today, including the utility knife as well to create some as-built joints. Let's walk into that, right? So I'm going to open up, I actually already did open up this utility knife, or maybe I didn't. There it is, a utility blade. And this was designed in place. If you look at the sketches and you go through that tutorial, which is really helpful, and I recommend going through that tutorial, you can see that this was designed from some basic sketches, right? Position for the blade, how our slider knob is going to be assembled and so forth and created. So I'm going to hide those sketches for now, but notice that this slider, and it's also assembled with the blade, is not really aligned to anything. It doesn't really have a joint at this point. I'm going to jump back, and I want to give you an idea of how to work with the designed or as-built joint. So if I go and choose as-built joint, right, we're going to capture the position since I moved it in space. We're going to capture where it's at. And now we have different types of joints, but the first thing we select is the component. So since this was designed in place, the actual knob is where we want it in space of this design. We can capture that without having to select multiple components or faces or bodies and so forth. So our first component will be the moving component. The second will be the blade housing that we're looking for. Our position is where it is in space. You could decide wherever you want that position to be, right? And right now it applied it as a revolute joint. That was the last joint that I was working with. And of course I could change this to become a slider joint, right? We don't really want it sliding in that Z axis. We want to slide it, let's say in our X axis. That looks pretty good. And again, as you would imagine, if I chose the y-axis, that's not exactly what we're looking for. And I'm going to slide this along the x-axis. And now we have a slider joint. And now we can make the limits between these points, or we can even do what's called a contact set. So it's going to go right through. And we can set up a contact set between these faces. Um, let's jump into the concept of a contact set. What does that mean? So it's basically putting a boundary. So as this knob slides, it's going to recognize the boundary of the other body and it won't let us pass through. And here's a great example of a contact set. Again, in that same folder, you'll find this Geneva drive, right? So this is a good example of being able to set up and have a contact point, right? Or shall I say a contact set, right? So in here we can enable that. So before we do, notice that I have this rotor part, which isn't all assembled yet. So I'd have to, if you imagine, I'd have to put all kinds of joints on this. I'm not really worried about how this is going to rotate, how the clevis pin is going to be on there. I'd like to make this all one rigid group, right? So almost like a sub-assembly. And what we could do is we could select those components. So there's our rotor, right? And all the components in our rotor. So as you can see, this is also a top-down design. I'm going to select those components and we're going to go up to assemble and make them become a rigid group. So a rigid group is going to take those components you select, we're going to capture where it is in space, and now we can apply a group to those components, right? So we don't have to make individual joints of each of these components. We can now group them together, right? And we can even grab child components, so if there's a subassembly of a subassembly, it'll grab all those as well. So now I just made it into a rigid group. I can move them around, and they're not going to separate those different components, because my main purpose of having it here is just to show that contact set. So let's assemble this now. So now we want to add a joint. As you'd imagine, we probably want to make a revolute joint between this face and this housing in here, this spacer. So in assembly, I'm going to go in to make a joint, capture the position where it is in space, and we can always delete that position marker too. And let's grab this at the center of that part, and we're going to go into here and we're going to add it to the center here. And if you want to, you can also get the cylindrical face as well. So I don't, of course, don't want it to revolve in that direction. So I'm going to change our motion, and we're going to do this around the z-axis. Now we have the revolution or the revolve joint the way we like it. So now I can revolve this part, and this one already has its revolve on it. Now, to give you an example of the contact set, the way we would work with this, if I go into assemble and I'm going to enable all contact, right? So now it added in here our contact all sets, and we can start to add a new contact set in here, right? So let's add a new one, right? So I have one here that's already created. We can take that 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 contact set out. And let's go and add a new contact set. And what do I want? What bodies do I want to contact? We could select these bodies or this body here. I'm going to select this body, and I want those to recognize when they're in contact and apply that joint as it should in the real world. So now as I start to rotate this around, if it'll let me rotate it, grab my joint, there's my revolute joint. My contact set should now rotate around. It's funny that it's not. Usually it'll work. So I think I have my two revolute joints. Let me go and animate this real quick. Let me edit that joint. It says it's going to resulting oh, I have a conflict there. So let me take this contact set. Let me back up real quick because I actually still have a contact set there. Let me back up real quick. There we have this revolute. This is revolute. And now it's going to contact, right? So if I roll this back and I move this into position, now if we actually have this thing slide, you can see it's now going to enable a contact set, right? So I actually had two contact sets set up there. So in here you can see as that pin rolls around, when it makes contact, it's actually moving the other component. So you can mimic the way components are going to work in the real world when they contact each other. Right, so this is a good example. There's a good tutorial in our main tutorial inside of this set here, you can see there's a Geneva drive that you guys can practice this directly. Another example of a contact set as well as other types of joints, like motion type joints, I actually have this engine display, and this is another one that I actually got through GrabCAD, and it's one that you can download. But this enables contact sets, but I also have motion and drive joints in here. It actually shows the motion, so I have a rotary joint between the camshaft, or in this case, the crankshaft. There's the camshaft. The crankshaft and the component. So as I move it, it recognizes that boundary. And I also have a motion contact set. So that's what this is, motion link. So when you set up a motion link, and we can go through that, right? So if I go into joints, and I can see I have a motion link between two joints. I'm just going to edit it real quick. So I have a rotary joint or rotation joint of this for the top gear. I have a rotation joint of the bottom gear. This is the connected from, or the driven gear, the slave gear, and I have a set of teeth on here, and it's actually a two to well, it's 180. It's it's 2 to 1. So every time I have one full rotation, this is going to go 2 rotations in the other direction. So I just simply set it up with the angle that we start with. So for every 360 degrees of rotation, the other driven joint is going to go 180 degrees. Right, so we're actually going to reverse that. It's actually the second joint is going to go 180 degrees. This is going to spin twice, so it's the other way around. So now we can actually, if I animate, you can see those joints working in place, and everything that goes along with that set is also moving in place. Now, we did set up contact sets for these these lobes, right? So for these cams, when they touch those components, it'll raise them up, and it will mimic actually the way the valves are going to open and close with the timing in this one, right? So that's another example of using a contact set between these different faces, right? So, and I think I had those turned on. I'm going to go back up and enable them. So let's enable our contact set. So now if we actually go in and show you motion, if I go to edit and we're going to play through, you can actually see it's going to start lifting those lifters. You see them actually moving, right? So you see the rocker arm up here is actually moving when it comes in contact. So you're actually mimicking the way it's going to work in the real world by using contact sets between the cam and the lifter, right? So this is another good example of being able to set up those different joints to be able to mimic what you're looking for in the real world. Okay, so we walked through some top-down design. We walked through some ways to apply different joints, right? We looked at different ways the joints are applied to different components. We did look at our as-built joint when we did the blade, and we showed you that you can actually have it update the joint in the way it was built. Joint origins, I'd like to show you this in a different context. We're going to jump into another assembly, and then at the end, we're going to do some motion study in here. So let's talk about another assembly, right? So I was showing you this vise assembly, and I'd like to set this up with a motion link to show you how we can make the gears move and so forth. Or in this case, not the gear, make the drive screw move the vise back and forth. So let's add some joints. Now the first ones we want to add in here. So I have a rigid group for this um, moving jaw, and we're going to assemble this lead screw in the middle of it so it moves it back and forth. So the first jaw or the first vise movement we want is a slider joint between this face and this face, or you could do a slider joint between the center of this part and the center of this hole. It really depends on how you want to set up your design. So the easiest way for me is to make a joint. So I'm going to assemble, add a joint. We're going to capture position since I moved these two components out in space. And again, I'm going to apply that origin, right? So that's our coin right there. I can see the x-axis is going to be along this face, right? So our z-axis will be the face coming out. I'm going to select that face. Our fixed component will be this face. And now it aligns them. I want to make this a slider joint, right? So let me go and change that into a slider joint. That's what I'm looking for. And now we have a slider joint for that fixed jaw there, or I'm sorry, the moving jaw to the fixed jaw. We could put in our joint limit while we're here. We're going to say our 0 limit. We don't have to move it, but I can go into here and say, okay, I want to edit that joint. So it's actually down in this vice handle assembly. That's not exactly where I wanted it. No, that's not where it is. Go to my joint. Let me back up. So I have a rigid joint. That's our interesting. I have a rigid joint here. That's not actually what I'm looking for. So we have a vice handle in here. Let me delete that out real quick because I think it's causing a little bit of confusion on my end. So now there's our origin. I got rid of the vice there. Our slider joints in here. So if I go into this component, which is our vice component. So in here we have a rigid group and the slider joint. So now I'm going to right click on that slider joint and edit the limits. And our minimum is going to be 0. Our maximum will be, let's say, 6 inches. And I can see it's going to go for the ride, so 6 inches minimum. And we can also make it a little bit longer if we want, but now we have that slider joint. Now the next joint I want to make would be our lead screw, right? So it's going to actually rotate, and I want to kind of mount this edge in here to the lead screw, right? So let's say we're going to do another joint. We're going to assemble, right? So I'm going to add a joint, capture where it's at in space, and I'm going to use this center. I could use the cylindrical center there, and I'm going to use this cylindrical center, whoa, on our vise over here, right? So let me go into this cylinder. I'm going to use that cylindrical center, and it lines them up. And I want to make this become a motion joint. Now notice where I selected. I selected in specific places on purpose, right? So if I go back to our first selection, I selected this face over here. So I want this to align this cylindrical face to that point. I want that to be aligned in that positive direction. I want it to align that, if we look at where I selected, on this face opposite in that cylindrical face. So it depends on where you select, or else you're going to get your lead screw flipped around in the other direction, right? So be mindful of where you're selecting and what parts of the bodies you want to have in contact, right? So I selected those two different components, and in here I could say I want that to be a revolute joint, and now I can make this revolve. Now, the neat part about getting some motion, now these are completely independent, right? So the slider joint, and a rotary joint, I want to combine those, and what I'm going to do is create a motion link. The motion link is now going to combine two different joints together, right? So I'm going to capture the position. So if I selected two gears, right, they both had revolute, now I would be able to do both angles. In this case, I'm going to select our slider joint. It has the distance, right, where it's at the moment. So it's almost like adding that position or drive link or drive joint. But now I'm going to select this other joint, which is our revolute joint. So now it's saying, okay, now I have a distance it can go for each revolution, right? So now I did a little bit of a quick look where this is a inch 12 lead screw, right? So that's our pitch. That's for every inch, you're going to get 12 threads, right? So, and you can look this up on a chart. So 12 threads is going to give us an actual distance it's going to travel. So I'm looking at how far will this travel for each revolution. In this case, it's actually going to go 0.083, right? And that's the actual distance it's going to go as it does one revolution. And you could find this on the internet, or you can even do some calculation on your pitch versus your linear motion, right? So for each revolution, this is going to go 0.083 or 83 um, or 830,000. So it's actually 83,000. So I'm going to say okay. And now as you see, as I start to turn this, it's actually moving our jaw in that direction. So it looks like it might be going backwards, right? So it's moving away, right? So it should be pulling it closer, going reverse, I think, on this thread, right? So reversed. So actually, no, it's actually moving the way it should. So, and if you want to reverse that, you just simply go back in to your motion link, edit that feature, and then you could change your direction. You can reverse it so when it goes 360 the other way, it's going to move in the other direction. So now we have that motion link. A couple other joints I'd like to talk about would be making the handle for this component. We're going to add a couple different types of joints there, right? So let's do it. I'm going to go and add a new design. Now this one, I'm not going to design top down, right? So I'm not going to draw the hinge, the pin, and the handle all together in this design. Now I want to make a bottom up design, right? So now I have components and I want to put them together. I downloaded them from the Kurt website, and these were downloaded, the pin, the shaft. I have the lever. Actually, this isn't it. Those aren't the pin and shaft I'm looking for. If I go into my data sets, I'm going to go into my project, and this is my data panel. And in here, you can make all your different uh, selection sets and so forth. So in here, excuse me, animations in my assemblies. Here we go, my assembly. So now I have that Geneva joint, and I have a couple other assemblies, but I have a vice handle, right? So I have a vice handle, the vice hinge, and a pin that I'm going to use to put together. This is an example of bottom-up design. I already have the components. I want to assemble them in this environment. Notice, right now we don't have any kind of assembly environment. It's just a single part with a single origin. If I start drawing sketches and bodies, it'll just be a simple part. But now we're going to turn it into an assembly by inserting a component. So there's our vice handle, hinge. So I'm going to right click and insert into current design. It's now going to take that vice handle that was already previously designed. Oh, it's giving me a warning here. So you have to save your design. Right now it's untitled and it has no save data because it doesn't, if you look at it from a data point of view, Fusion doesn't know where that vice handle is going because this doesn't exist yet, right? So we need a version 1. So let's do a quick save, and we're going to call this one our vice handle assembly, or just VHA. Save it, since I already have an assembly in there I did earlier. So now we're going to make this new vice handle assembly. Once it saves it, we have a version 1 that exists now. So let's take that handle hinge and we're going to insert it into this current design. Now it places it in some position. If you'd like, you can move this around. You can orient it the way you'd like. I'm going to leave it in as it is. We're going to say OK. And now we have this component. Now notice there's the link. We have a linked component now. It's not designed from the top down. It's now we're designing this from the bottom up. Notice that our icon turned into an assembly, and now we have this component which has its own body and sketches and data. It's all part of this design, right? So now I'm going to insert another component. We're going to get the pin in here. So I'm going to insert the pin into this design. So, and again, you can orient it, you can move it the way you'd like to. I'm just going to leave it the way it is in space. And the same thing, we're going to grab our vice handle and we're going to insert that into this design as well. So one concept to think about is that all these components can move around in space. Notice when I move that, the position marker popped up. If I undo, the position marker is gone. If I move it, the position marker is saying, hey, you moved it some distance in space. Do you want to lock that distance down that you moved it? Now I'm going to undo for a second. I don't want to move the handle. For this is subassembly, I want this handle to stay, or this hinge, right where it's at. So I'm going to ground it. So I'm going to right click on the hinge and choose ground. That's going to place it exactly in that position. It's not going to move around, and you can see this little pin, and you can see the pin on our timeline. So now I can't move that hinge, but I can move the other components. I'm not really worried at this point of capturing that position, but if I did, it won't ask me when I make my assembly later. So in the meantime, I'm just going to capture that position. You can see on our marker here. So if I move this, if I go back in time before I even captured that position, it puts it right back to where it was, right? So let's now talk about the joint origin, right? So what I'd like to do is I want to assemble this with a joint origin. What a joint origin, it allows you to do, it place a joint um, a coordinate system on the model prior to any joints, right? So I'm going to choose to do a joint origin, and I'm in my assembly mode up here. Now I have some choices. I could do a simple joint origin, right? So I can grab some place in space. I could do between two faces, right? And I can also do at an edge intersection. Excuse me. If I wanted to grab an intersection between where this edge and this edge would come out to, you could do that here, right? So in this case, I'm going to choose between two faces, like this face and this face. Now, what I didn't do is I'm not applying that joint to my overall assembly. So it's not giving me that joint origin because it's not placing it in the assembly mode. What I need to do is I need to now place it inside of the component, right? So there's the hinge, and I can create our joint origin between them. There's another way that I can work with it, right? So if we extend down, you can also edit in place and work with it directly. We'll talk about that at another workflow, at another live stream. The other way to work with that is you can now apply a joint origin directly inside of the joint between two faces, right? So if I do an assembly, and under joint, I have also the at intersection, and I have also the capability of doing between two faces the way we would do that origin, right? So I want to place the origin between those faces there, right? So let me go and cancel this real quick. I'm going to go into my overall assembly. And for this component, I want to add a joint. Oops, sorry guys. So I want to add a joint in here, assembly joint. It's funny that it's not giving me my overall. Oh, yeah, okay. So my moving component, that's my fixed component. It's not going to enable me to set up my fixed component. What I want to do is now I want to add the joint to the moving component. So in here, I can select an edge. And notice I can also do between two faces. So I can grab this face, and now I can select the plane that's directly in between those two. So now I know I'm going to be on center with the part that I'm going to select. Now I could select my fixed component, right? So now I have that oriented, and in here I could say between two faces, between this face and this face. I'm going to select this center origin. See, it projects the origin to the center of that component. And now it aligns our two components together, and I have it set up right in the center between those faces on those components. So now we want to align our pin. We could do the same thing here. So if we do assemble joint, right, and I want to get between those two faces like we did before, this face, we're going to select that center plane. And we'll do the same thing here, right? So we could say, and I can choose the center plane. Or I can also hover over in between here. And you see I also have access to that joint we did earlier. Right, so now we have our pin right down the center there. So now we have this motion, right? Now, if it goes right through, what do? We can add a contact set, or we can put limits between here. But I'm going to use a contact set, so I'm going to go to Assemble, go down to here, Enable Contact Set, right? We're going to make a new contact set, and we're going to select this handle and this hinge, and now it won't go through it. It'll stop when it hits the hinge, the way you would expect it to work in the real world. So now I'm going to save this. Now we just made a bottom-up assembly. Let's do a quick save, right? And it's going to save it as our VHA. And now I want to apply that to our vise, right? So let's bring it into our vise. So let me go back into our vise assembly, vise example. And I want to bring that handle in here. So it's like a combination of a top-down, in this case it's actually top-down assembly, and we're going to insert that vise assembly into here, right? So insert into our design there. I like that between two faces because it's going to help me get this hex on here. So there's no round edges, there's no round faces in here. Let's go between two faces, right? So we're going to make a new joint, assemble joint, right? I'm going to capture the position where it's at. We're going to say between two faces, let's say this face and this face, right? We're going to get that center plane between those faces. And I want to align that to this component. And we're going to say between this face, before we do that, let's go into face to this face. And then we're going to get that center plane, right? We can even select this edge for the center plane. And it aligns them. And now I have that handle aligned, sort of. We could flip that joint. Actually, it doesn't look like I grabbed the components correctly because it's flipping it around. Let's go back and see what we did. We can unselect these guys. I think it was this selection here between this face and this face. We're going to grab that center plane. I don't want a revolute joint. I want a slider joint along the Y. Oh, in this case, slider joint. Looks like I'm backwards. Looks like I selected it wrong. So let's go back and take a look. So it looks like this first position I didn't get correctly. So let's go in between the two faces again. Let me grab this because, whoa. Sometimes you can be, when I did that center plane, it might have grabbed it off of a different place, right? So now I can see it projecting to that point, right? So the coolest thing is that now you can go back, and if I flip this, it should now align the way I'd expect it to align, or not, or it's not going to work for me. But yeah, so I can rotate this around so, and then slide it onto there. So so there's ways that you can, a lot of different ways to get your assembly to work. Sometimes it'll flip in the way you want it to. It depends on how you select it. In this case, I thought I selected it right, but it gave me this kind of flipped over view. So now we have that aligned, right? So now if we start to use our handle in this design, you can actually see it start to turn. Right now it's actually pulling the handle around, but now I can start to spin this handle. Oops. Oh, I guess I didn't align it. Oh, I did, but I didn't fix it. Right? I didn't give it a fixed component or fixed direction there. Right? So face to face. But as I turn it, you can start to see it's turning our and moving our fixed jaw there. Right? So then I just have to fix it in place. That's all. But now I can do that revolute joint. We were able to assemble this outside. It keeps that same assembly contact set, usually, right? And now we have that sub-assembly working the way you'd expect from that previous design. We added it into this assembly with our vise. So the last thing I wanted to show you guys, we have a couple minutes left. I'm going to jump back into our X carve. Now, it's pretty powerful to be able to see exactly where the the router is going to be, in context. I don't even have my tool on here, but I can see where the router is going to be in context, and I can even use this to help and kind of show if my clamps are going to be in the way. If I'm going to hit the clamp, looks like I might hit right there. So if I did this right and I designed it right, matching the clamps that I 3D printed and the ones that are going to work right, I could see I might have some potential collision. So I'd like to keep that tool in this area, as I do my CNC, and I want to be able to check and make sure I'm not going to go across there, right? So I want to mimic the way I'm going to program this. So one neat way and a pretty cool tool that you can use is actually called motion study, right? So I'm going to move this back to its zero. So I know the zero of where this component would be, or this part, and I can move my Z down to my 0 point. And I know it's going to touch off at my zero. So that's my machine zero. Of course, this is going to be all the way up, but when I touch off, I have a plate that I would use where I touch off the tool. And if I know that zero, I can mimic the way it's going to move in space. So if I assemble, and down here's a motion study. And this is a place where it would probably be helpful to be able to see what's going to happen in the assembly as I move through space, right? So on this assembly, I have a y-axis slider joint. So if I select the y-axis slider joint, that's moving along this rail back here, right? That's my y-axis. And now it gave me this curve right here, right? With a timeline, if you will, right? So position markers. And then I have my y-axis joint, right? So in here, I can put in a specific value where I want that joint to be. And I'm going to select along this curve some point, right? So let's say we select right here in here, and it puts a point along that curve. And I could say my step would be at, let's say, 10 seconds or 10 frames or however you want to put it. And I want to move that y-axis. Let's say we're going to go, in this case, negative because the way my joint was set up. And I'm going to say negative 4.5 inches and enter. So it actually moves the design. So if I move forward and backwards through time, you'll see it'll actually move my assembly in that direction. So it's basically kind of applying those those drive joints, but it's applying it in a way that you can almost animate it. In fact, you can even use this in an animation. Now I have a Y or Z axis. So I want to raise this up. So on my gantry down here, I actually have a Z axis motion. My Z-axis, I just simply select it. It brings it into my motion study. And let's say right after that, let's say right around 12, my Z-axis, I'm going to raise this up, let's say 1.125 inches, right? So I hit enter, and now I have it raised up and it's 1.125 inches. So if I move back in time, I can actually mimic the motion of the machine, right? It's going to raise it up there. And now I have a x-axis. So I'm going to move this over and try to find the origin here. And I know where it is, but I want to be able to move it along this axis, right? So now I have my gantry, my y or x-axis there. I can select my x-axis, Should bring it right into this graphic. Now I could select the x-axis. Let's say at this point, around 18, I want that to move, let's say 6 inches over, right? So now I have it moving 6 inches over. That's too far. It looks like it's pretty low into my stock, right? So I'm going to go back over. There's my z-axis. I can also select them out of here too, right? So there's my z-axis. My z-axis point, I just added a new point. If I don't, I could just delete that. My z-axis point, and actually that's sort of along that line I grabbed it, so I can go back and fix that. But let's say at this point, at my 11 marker, I can make this 12 marker. And we'll keep it at 11 for now because I already have one. So in here, I could say I want to make that, let's say, 1.25 inches, so I want to raise it up a little higher, right? So now I can see it raised up a little higher. At that point in motion, it's going across, and then maybe in my x-axis, I probably don't want it to go all the way over. So let's say we're going to make this 4.5 inches, right? So now I can mimic that motion. So, and that's actually 4.5 inches from my 0 where I have it set up. Now I can add other points, right? So let's say, excuse me, further down the line, let's say at some point in here on my x-axis, I want to move over to this other side of the stock there. So let's say at the 35 marker, I want that to move, let's say 18 inches over. So now I can move along the x 18 inches over. Right? So it's actually zooming out, as you can see, kind of zooming out in our motion there. So now I can actually um, mimic, and I can kind of go through a motion study and see exactly where the tool's going to go. And now I can start to move back, and I can see I'm going to be clear of our vices there. And I probably want to go a little bit further to get around the side of the machine, so I can always go back in here and say, instead of 18, we'll make it 19 inches, and we'll move that over. And maybe I want to start to move the Y back. And I can do this simultaneous as well, right? So let's say along this Y axis here, and in the Y axis, I'm going to put a point maybe just before that, right? I can even make this at like say 32. I want to put a point, instead of going negative 450, we're going to go negative 18 inches, not 81, 18 inches. So now we actually have that motion. So it's going to do the X and Y at the same time. So I'm kind of mimicking what my CNC is going to do, and I can see where it's going to go and if I'm going to hit any clamps along the way. So it's a way that you can use a motion study to determine, the motion of the machine, if it's going to go in an axis. Imagine if you have the 3-axis or a 5-axis machine. Is the machine, as it goes into those positions, is it going to move to a place that's unsafe? Or is it going to move a way that the machine can't do? Right? So just to show you that you can use those joints that you set up, and you can actually do a study, and you can later on, you can save this out of a, if I jump back here, I'm going to play through, you can see how it's going to move across. You can actually mimic it, that it's going to actually cut some pockets or however you want to do it, right? So slow the speed down, and you can also save this. If I say OK, now we'll have a joint. Under the joint, we'll have a motion study in my main design. So it'll update. And then we'll have this motion study. We can always go back in time, and we can replay it. So now under here, I have motion studies. I have my motion study one I did earlier. I have this one we just did. We can always go back in here and edit, and we can also play through, and we can save that motion study for an animation and so forth. So hopefully that's been helpful to kind of see some ways that you can use joints, right, to mimic the way that your machine's going to work or different components are going to work in the real world. There's ways that you can do drive joints to position your components where you want them, right? And under joints, there's different applications, different types of joints, right? You slider joints and cylindrical and ball joints that you can apply. We talked about the um, the the position marker, and that's not in this case, the origin, right? We talked about we're setting up a coordinate system using the joint origin. And that coordinate system is basically an X, Y, and Z that you're applying to a face or to a part or cylindrical face. And then you can use those coordinate systems to combine the parts together, right? As built joint, you can use the design itself to build in your joints, right? Rigid groups, you can make your sub-assemblies for this level of the assembly. Drive joints, right? So we're able to put or mimic where the part's going to be or where the assembly will be at that specific point in time. Motion links, so if you want to apply gears and threads and so forth and watch how they're actually going to move in your design, you could do a motion link. Contact sets, like we saw. In the Geneva drive, you could try that out, and the data sets here already in Fusion. And go through and see how you can make different contact sets, like we showed with the engine, right? So those, actually, we could jump into here. This is a great use of contact sets, right? So as we move the components, the gears around, it's kind of looking at a weird position there, but as we move the gears around, you can see where the lobes of the cam are going to push. They put the extension rods um, or the rods up to move the rocker arm, right? So those places you can use contact sets, right? And so just to recap, we've gone through a lot of those different ways, especially down to motion study, that you can actually use those joints to help you um, kind of really look at what your design is doing inside of Fusion. So with that, I think we're at the top of the hour. Thanks for joining us today. It was fun going through and bringing you guys deeper into what the joints do and what the assembly components. And so, yeah, please reach out. We're going to be checking those questions. I know we had Tyler manning the keys, answering those questions for you guys. So hopefully, again, this has been helpful. And tune in all week. We have electrics workspace or electronics workspace with Jorge and Edwin tomorrow on Wednesdays. Thursdays work with Brad and Jason and you'll see Lars and those guys joining in on some of Brad's projects. And on Fridays, hang out with CJ, CJ and Al in the morning to get a good view on what's happening in CAM. So awesome. Yeah, so thanks for joining us, guys, and we'll be seeing you really soon.